the link. Like here, yeah. It's a form of gratitude to people who are here in person.
Exactly. It's a personal speech from the CEO.
Yeah.
Oh, to log in. This is being recorded, right?
Right. So Alvaro is also an author of a great security plugin, right?
Was that a joke?
Just so they know that what you just did is very proper.
Yes.
Also, I saw if you can paste also the YouTube link. If for some reason they don't want, maybe you will pass. Because this is just read only.
The matrix. Exception, yes. How can I see if someone is connected? There's nobody connected, right?
At the moment, no.
No, there's 0 spectators.
So sad. All right, let's start. So welcome everybody. Thanks for coming. Right. It doesn't hide. Never mind. Maybe I can. Does? So I'm going to talk to you about Ratpack.
Hi.
That was me.
Yeah.
Okay. I'm going to talk to you about Ratpack in this uniquely crafted presentation for this user group, as you can see. This is 3 days old, so it's
also
yes, I will rebrand it. Well, about me, I will just say that I'm coming from Spain, working in Java a few years. I contribute to some open source projects like Rails or Ratpack, and I normally speak at different conferences. As of today, I work at For Finance. It's a financial company. We use a lot of things, and it's a web page where you can submit your CV if you want.
But you don't recommend.
I didn't say anything. So I'll start with an introduction about the thing. Then I'll talk to you about the core concept of Ratpack, which is the handlers, context, a little bit about modules, and then some words about the synchronous and non-blocking model, and finally some questions if you have them. This is all published already. The slides are on that link. There is a companion code that I will use for the demos on this session, already published there. And there is a workshop version if you want to practice yourself doing some.
The project was started by you?
Ratpack? No. That's not no parallel tracks in the Groovy user group. Right. So raise your hand if you know Java. This is a Groovy user group, but who knows? Groovy. All right. Spock. Fine. Ratpack. Have any of you used Ratpack before? or you just know it?
Yeah,
You know Ratpack, or you know that it exists? I know it exists.
Okay. Fair enough. Regarding your question, why Ratpack? Ratpack is, well, I have here like the technical definition, but about the history of the project. There is a Ruby framework called Sinatra. I don't know if you know Sinatra. Sinatra was like a micro web framework for Ruby, right? So initially Ratpack, and Ratpack is actually a group of singers where Sinatra was one of the members. So that's the reason of the name.
That makes sense.
It makes sense, yes. Those geeks are smart. So initially it started as a groovy version of Sinatra. It has seen many changes over the last years. I think it started in 2011 or 2012, I don't remember. Let's say that the current version, which is the one that they have been heavily working in the last 2 years, is what I'm going to explain now. Because initially they was initially based on Vertex, then they switched to Netty, so they have changed that for a while. But they got like a 1.0 version in the last month, and it's essentially Java 8 based, so it's only Java 8 in the core. It is lightweight, very lightweight. You'll see that later. It is unopinionated. It's very flexible for you. It's based on Netty. You know Netty? Yes. That has some implications in terms of the API you'll have to deal with. So no servlet API. I'll talk about that later. It is meant to be designed for writing non-blocking HTTP applications. Non-blocking because the asynchronous features are built into the core as a first-class citizen. It's really easy to work with them. And HTTP because it's the main purpose of it. So APIs, essentially. It's focused on performance and efficiency with an emphasis on testability. This is really important. It's really easy to test a Ratpack application on a functional level. And as a user, you can use either Java 8 or Groovy as programming languages. But this is the Groovy user group, so it's Groovy. Question? Yes?
Mm-hmm. So what do you mean when you say unopinionated?
Opinionated is when the framework has opinions on how should you structure your application. Mm-hmm. That's what means an opinionated framework. So unopinionated is the contrary of that. It's not. It's flexible. It doesn't constrain you to build an application in a certain way. Mm-hmm. To give you an example, something which is heavily opinionated is Maven, mm-hmm. Right?
Yeah.
What? Or Grails. Sometimes, yes. When to use Ratpack? All the time, all the things. No, for microservices. Why? Because it's the word everybody's talking about, so I had to put it here. And no, but it's really, I'll explain that later on. For high performance applications, so if you have like a real-time applications or applications where you need like a really high throughput, a lot of requests per second, this is really something you can use for that. They call this, that has like those toys, batteries included, so you can start playing with it without anything else. And the getting started experience is really nice, as opposed to other frameworks. And this is a personal opinion. So if you're writing microservices, why do you use macro frameworks? Like, for instance, Spring. So Spring is massive framework, even Spring Boot. So naked Spring Boot application starts in 4 seconds, 3-4 seconds, more or less. Ratpack a naked Ratpack application starts in milliseconds.
And the naked Spring Boot application is pretty heavy in terms of megabytes.
Yes.
You can just watch how much you have to deploy.
Both of them do nothing.
Most of them, yes.
Both of them.
Oh,
Naked,
both of them, yes.
Naked Ratpack and naked Spring.
Of course, of
That's
course.
true.
But at least the Ratpack one is much faster.
I'm doing nothing.
Yes, correct. Have any of you used Vertex here? Like used or?
And I hear that this is something similar.
Yes.
All the terms of features.
Yes, and you have used Vertex as well?
Yes. And Spray. Which is also
Mm-hmm.
and Sina.
Nice. Don't make any question. You know too much. So Ratpack is developer friendly. The startup is in milliseconds, and this is really handy. There is a development time reloading of resources, which happens as well in milliseconds. And they use the Gradle continuous build feature, which is like a last month addition to Gradle. So essentially, they integrate very nice with Gradle out of the box. Everything works, and Gradle is running a daemon and is scanning your source directories, your source set, to be more specific. So if anything changes in your source set, Gradle will trigger a rebuild of the project. And because it's so fast, you'll see later, you won't have time to command tab to the other window to refresh, right? Gradle is going to be faster than you. They have first-class support for functional testing. So by functional testing, I mean starting up an instance of your Ratpack application, listening on a random port, and giving you an HTTP client connected to this random port so you can make HTTP requests to your application. This is really important, and is 2 lines in Ratpack. And making unit tests is a piece of cake as well. It's really easy. So you just use Spock or JUnit or whatever thing you're into, and that's all. There's nothing special. So let's see some examples. The very basic way to get into a Ratpack application is with a Groovy script. Says this is how it looks like. This is a really simple example. So we have an add grab annotation. You should be familiar with this. And then what we see here is the Ratpack DSL for Groovy. This is nothing than a method call. It's a method called passing a closure. Without telling you that much, you can guess that you probably can get what is this doing, right? So if I have a get request with something in the path, then this guy is going to be executed, and otherwise this is the one that will be executed. And if I, let's say, capture variables from the path, I can refer them to them later on in the code, right? So let's see how this works. The script version doesn't give information, but I don't know if you saw when this icon appeared. That's the start point. So if I make a call request to the root, then I get hello world. Let me because this was the case, right? There was no path. If I, however, make a request to this is what is the group, hello whatever, right? Which is what I capture in the path here. So far so good. Nice. Okay. Obviously, this is suitable for really small applications, right? So if you need like a proper application, a proper project, this is not the way to go. The way to go is through the Gradle-based project. To get started with that, there is a tool called Lazybones. You know Lazybones? Lazybones is a scaffolding tool for different projects. So you can use it to generate, let's say, they have like template definitions, and they help you start with the different projects, including Ratpack. If you know Geoman from the JavaScript world, it's the same thing. So to create a new Ratpack application, you just say Lazybones create Ratpack, which is the template name, and then my application. And then you go to my application, and then you say Gradle lovely run, and this thing just works out of the box. It's really handy. Compare this with, for instance, Vertex. Vertex is really painful for these things, so it's not that straightforward to get started. So how does a Gradle-based Ratpack application looks like? Gradle wrapper, nothing interesting here. And then we have the SRC main Groovy directory with our classes, wherever they are. And we have a special SRC Ratpack directory where all the Ratpack specific stuff goes into. The main file is the Ratpack.groovy file, which contains the Groovy DSL we saw before. So if I so this file is essentially the very same thing, right? And then we might have optional content, like for instance, static resources or templates or whatever. So that normally goes inside there. And then we have the typical test Groovy application. So I can run this by simply Gradle w-run. And then this default application is using the Groovy markup template with a template here, which is a HTML page. So that gives me an HTML content. Let's open this project in IDEA. So if I run this project -t, this is the continuous build in Gradle, starting from 2.6, I think. So you see Gradle is listening for changes in the source sets. So for instance, one thing I could say, well, the most basic change is to make a change in this file, but it will get caught even though you don't have the Gradle continuous build. But you could, for instance, I could refactor this into a class, right, and create the class, so that will have to be reloaded. For this demo, we'll make this change. I switch. You see how Gradle did the thing faster than me switching. And then we have the thing here, right? So that's the development time reload. No questions so far? Nope.
What does it use for reloading? Because one thing is compiling, which is what Gradle provides, right?
Mm-hmm.
But then you need to reload classes.
That's a whole build. So if you see the output.
So it's restarting everything.
So it's restarting together. So then it works well with Ratpack because Ratpack starts so fast. So it wouldn't work with anything that starts slow the same way.
Yes,
Okay.
they used in the past spring-loaded. Spring-loaded is a Java agent
Yeah, I know. Yeah.
that does a hot replacement of the changed classes. But it's tricky. It doesn't. It's like a poor man JRebel. So it's like JRebel not working properly, right?
But for free.
For free, correct? So they say
Well, it works a little bit, okay?
yes. For the most basic changes, it works.
For front-end front-end stuff like templates, it works very well.
Yeah. But the guy said, "Oh, come on! So who needs that? Who needs that if the startup is so fast?" So and actually, if you use a Gradle integration, this executes everywhere on all IDEs and everything. So they got rid of many issues they had.
Sorry, Alvaro, could you please show the Gradle script?
Yes. Have this here. So this is black.
It's not black.
It's the Darkula
Yeah.
look and feel. Don't tell me you're using the white
No,
background.
It's black, but it's not black. It's some.
But that's because of the brightness of the screen. So if you see my computer,
Except your terminal was black. This one is.
no, but so if you see this is the proper
Now
color.
Switch to the terminal.
Yes.
See how black is it?
Yes, because this is black, but Darkula is not. Blackula is Darkula. And after this, this is the graphical build. There's nothing special here.
Yeah, but I see that you have also imported the shadow plugin, so I guess that Ratpack can be started
As a fat jar.
as a Java process, or
Yeah, you can create a fat jar.
or using Gradle.
Yes, so Gradle is for development, but if you want to deploy this somewhere, you create a fat jar.
Okay, great.
Yes. Handlers. So I told you Ratpack is for HTTP applications, so think about HTTP all the time. So when an incoming request is passed, is coming, it is passed through the handler chain. In informal definition, you can think of a handler as a combination of a servlet and a filter, right? But forget about the servlet API at all. So a handler can either respond to the request with the usual things, so it can sound like I don't know, the body or the headers in the response, all the usual stuff you're used to do. They can delegate to the next handler in the chain, or they can manipulate the chain, like for instance, inserting more handlers dynamically or whatever you want to do. Each handler is given a context instance so that they can interact with the request and response objects to like read the body, read the request headers, cookies, anything that's coming from the client. The context will give the handler also access to the registry. We'll talk about the registry later. So as I told you, Ratpack is not based on the servlet API. So there's no HTTP servlet request, HTTP servlet response, HTTP session, nothing about that. Let's see some examples. This is a little bit more complex chain. We can have a look at the rest of the elements on the projects later, right? But for now, let's focus on the chain, right? So when we say all, means that the handler is going to be executed for all the requests, no matter the path, no matter the method type. You're not putting any condition on it, and you can use that for login requests or things like that, right? So
about the order. What's about the order? Because then you're calling next, which passes it through to the another handler.
yes. So the order is very important because they will be executed in the order they are defined.
Okay, so from top to bottom.
Yes, from top
Okay.
to bottom. Yes. So next is basically the next one in the chain that matches the request conditions, right? So here I'm defining a handler which will respond only when the path is full. Note that we are omitting the starting forward slash, but it is there, right? You can prefix or group handler based on a prefix. So this is, for instance, /API/methods. And then if it's a get request, you will see this. If it's a post request, you will see the other one. You can, of course, have handlers on their own class, because again, this is a closure, right? Which is probably enough for very small handlers, but if your code gets more complicated, then you'll probably need something else. So if we see, this is a simple class. So the handler method is like a functional interface, and it forces you to define a handle method, and you receive the context object that I mentioned before. The difference is that you have to prefix here all the calls to like a ctx dot wherever, ctx dot wherever, or unless you can use delegate to for that. Whereas here, for instance, the render method is coming from the context object and is an implicit call.
And what about response object? Do you have any access to the response?
Yes.
For instance, for setting any particular header? Or...
Yes. So within a handler, I have the request object. I have access to the body, cookie, blah, 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 and the response as well.
Okay.
Inside the content tab, the cookie scatter, anything you need. That's there.
The response object is passed down to the next handler.
Yes. The response object is all of them have. I don't know if it's the very same object. I don't know.
And the response object comes also from the context object, yes?
Yes.
Can you show the now handler?
Yes.
Oh, okay.
So this is like a get response.
Yeah, sure.
Okay, let's.
So this whole DSL here is based on coercion. So that all the end closures of the get, post, and so on are just being casted to the handler.
No, there is a get method that accepts a closure.
That accepts the closure. So when you're calling path there, right?
Yes.
Actually, no. This path is different, declared in a different way than the path below, the one with the class. The path with now, yes. Here you have a full class.
Yes,
right?
this guy is accepting a handler.
Yeah, I see.
So anything extends handler.
Okay.
So it's overloaded with many different options.
Yep. All right.
And for instance, in the Java version, you don't have anything that accepts a closure. That's the difference. But you can use lambdas for this because this is a functional interface. Any other question out there? Nope. So if we start this thing, and then So if I request foo, I get bar, nice. If I request, yeah, the examples I use are really smart and unique, as you can see. API methods. Get, usually get. Post, usually post. I request API. Now you see this response. The implementation is new data string. So
Could you please also pass the minus V switch?
in Chrome.
Yeah, I mean Chrom's output.
Mm-hmm.
I would like to see the headers. What about server header?
This one.
Yeah. Okay.
What are you
What
looking
did you
for?
expect?
Yeah, but when I was asking about server, for instance, Nginx is responsive with Nginx, you know.
So here you don't know what is Ratpack
Okay.
behind.
So
Is
there
it
no
good or
default,
bad?
server header for Ratpack.
No, there's nothing at all. But nobody's going to run that directly. You'll have a proxy in front of you. You'll have an Nginx. You'll have a proxy, Apache. That's the header you will see.
Mm-hmm.
And API Alvaro, for instance, and then hello. That's it. And if we see the console, we've seen all the requests being logged, like the URI, the path. All clear? Let's continue. The context. The context provides access to request and response objects. We saw that. You can interact with other handlers. You can use next. We saw that before, and there's another method called insert to insert a new handler for that particular request in the chain. And you can access objects in the registry. So the registry is like a Spring application context, more or less. It's a place where you can leave objects and then other guys can find objects there, right?
Before the IOC, but for the inversion of control, the pattern was to actually have a registry, to put stuff in the shared space where you could put it out, right? The difference is that inversion of control, you do not access this, you're given. Here you have to access some object to get something. So actually it's harder to test.
You can be given as well in Ratpack.
The object, so yes. It works with the IOC pattern.
Yes,
cool.
Yes. There are two ways to have them. So the idea is that if one handler needs to communicate with another one, they'll use the context for this. And the context is also used for dependency injection. So if you need like a service or a repository or anything like that, the context will help you.
What about the scope? Because you said that if you want to communicate between handlers, right?
Yes.
Okay, so is it a request scope?
It depends. It uses Google Use underneath.
Yep.
So with Google Use, you know you can bind objects to like for the JVM instance, or otherwise, if it's a handler accessing the context directly, is for that request. Because normally, if a handler is storing something in the request, is because it is something specific to the request that another handler later will need it. So apart from that, if it's like a service or something like that, then it's per JVM. So let's see example. This chain is more simple. We have 3 handlers here. We have this one that will execute regardless of the request type, right? Will execute always. So we're reading, you see we're prefixing this with this path, and we're defining a variable here that we are reading later on with this thing. So we read that in this string variable, then we create a pogo. This guy has nothing special. And then we make that available to downstream handlers in the chain. How do we do that? There are many ways to do this, but for the specific case where I just need the single object to be available in the registry, there is a single method, called single static in the registry class that will not do for you. Otherwise, you can always say like context dot put no, is set. Oh, it's a registry object. Registry dot set put. Where are you? There is a method to store things.
Maybe get.
Yeah, that's because it's using optional from Java. Whatever. So how can we access elements from the context? There are 2 ways. In this case, we have like a handler class. So there is a simple get method from the context. I pass the type, and if it's any instance of that type, it will give it to me. That's the I go for it. And the other way is I declare a closure parameter like this, and I will be given automatically that object if it exists. Okay. Let's run this, and then I'll show you the test because I have tests for this.
Does it work the same with the handler objects when you have a separate class that you can just declare what you want and you will get it in the method?
No.
So how does it work when you have a separate object?
You have to use the context for that.
Ah, okay.
Because this method is coming from the interface. You cannot say, I want this in a user object.
Yeah, but like with Spring Data, you can pass this. Like,
but that's magic.
That's true.
That's magic.
So you can have only one instance of one object in that context. In that injection.
Or you can have a map or anything else. And
but I mean, if you had 2 users in the context, what will happen if you try to inject user?
Is this user by default when you did what you did? Is it by default in a request scope only for the current thread, or is it for everyone and you can have only one user per whole application?
No, it's only for the current request. Which thread is that is not a simple question. We'll go into that later.
So you store by type.
You store by type.
Okay.
But this is like the very, very, very basic support. If you need proper dependency injection, you can use just properly. I think there is a later example about that. Let's run this and then see the tests. So yes, slash API slash username. This first handler will parse the request into an object and will make it available to the other handlers. So if I make the request just like that, I'm stripping this guy here.
Minus.
Oh. This is one executed. You see? Why? Because, well, this has been executed anyways. This one didn't, because there's no /API/something/h. So then we came to this handler here, which means that if I put this guy here, or actually not there, but well, let's see first of all the h1. So
if you did it on the top, you will have a null pointer because of the user.
Yes.
Okay.
Clearly. So yes, I'm 43, no, 41, no, 41, no, 31, 32. Close. I'll stop here. So we see this guy works. If I move this handler, well, actually the edge is this one, right? If I move this guy on top of it, right, and I use continuous field. See, I get the username. I get this guy. This guy is executing before, and it's not allowing, it's not giving a chance this guy to execute. Okay, that's the meaning of the order. What else? Let's see the tests. So I told you we can have unit tests, of course, and functional tests. For unit tests, other than using Spock, there is always a little bit help you'll need to mock things. So for instance, if you're expecting something to be in the request, it will be helpful to have like support from the framework to allow you to mock the request, or to mock like a parameter in the path or stuff like that. So this is how it looks like mocking in the unit test. So you create an instance of your handler. This is one of the reasons which is important to have your handler in classes. It's just testable at the unit level. And then with the request fixture class, then you can say conditions about the request. Like for instance, the path binding is how the substitutions in the path are made. So if I have like /API/column username, then I say that for this request username is full, right? Then I can have elements in the registry. I can I don't know, change the HTTP method, several things, right? And what I make is assumptions on the result of the handler, right? So this is the unit test, and then we have the functional test. I'm using the early access version of IDEA as well. There are two lines important here. This one is automatically making sure you have a brand new instance of your Ratpack applications automatically with your test on a random port, right? And this guy here is giving you an HTTP client connected to that instance automatically, right? Not only that, we're using a delegate from Groovy here. You know this annotation? Yes? Why? Because we can make things like, for instance, get test. This method is not defined here, it's defined in the HTTP client. So I'm essentially shaping things like that. Test client dots, test client dot, test client dot, right? We're making the test more clean. And this is HTTP based. So I'm making an HTTP request, and I make assertions on the response, right? So these are the tests for this handler. So API whatever, I get whatever, and then API whatever age, I get a number. Okay. If you don't trust me, which I wouldn't if I were you. We can test this thing. 3 days ago it was passing, so it is still passing. Any questions so far? No? Good. Modules. Well, there is a like a core integration with Google Use. Google Use is lightweight dependency injection. It is like a Spring but lightweight, right? So you can use it for for instance for your own components like services or repositories or whatever thing. Or you can use officially supported modules that are already packaged, and then you bind them in your Ratpack application. So the use integration is a first-class thing. So you can also package your own business logic into modules and then use it in Ratpack. There are quite a few elements which are already supported. For instance, S2 database, or I don't know, metrics from Yammer, I don't know, Jackson for JSON rendering, Pack4j for authentication, Hystrix for this circuit breaker pattern, RxJava for promises. You can use HTTP sessions. As I told you, there's no HTTP serverless request. Obviously, there's no HTTP response, session. But this module gives you the ability to have sessions. There's also a module to use Spring Boot if you are into that kind of things. What that makes is that you have a Spring application context backed context, if that makes sense. So the context object I mentioned before, we saw before, like the ctx dot whatever, is implemented via a Spring application context.
But that does it mean that there just is no more there for
Yes.
for IOC? So completely
well, the use probably is still there, but not for the context.
But for like handling the paths or
the context object. So if you store your users, or and also once you have a Spring application, you will have like a Spring Boot application.
Yep.
You can define beans there, like add bean or whatever.
Okay.
So those become available via the context.
Right, but then you would have a full Spring Boot, which means that it would start slowly.
Of course.
Okay.
It doesn't make sense.
Yeah,
I wouldn't use it. I actually did it for the homework of.
Yeah.
But only because Spring had to be there. So if you want the Spring, here it is Spring. But there are actually two ways to integrate the Spring Boot with anything, or in this case with Ratpack. You can have Ratpack like the main process, and then spin up a Spring Boot instance for the application context, which will slow the thing. Or you can have the other way around. You can have the main project is a Spring Boot application, and then you can embed Ratpack from Spring Boot. You can embed Ratpack from everywhere. It's just one class. You instantiate that class, and then you can define handlers and whatever thing you want. So there are two ways of doing that. But again, only if you have like a strong requirement to use Spring makes sense. Otherwise, it doesn't. So let's see how using Jackson looks like. This is a new section we're seeing here, the bindings. And if you have used use before, this will be familiar with you. So the module method expects a Google use module. In this case, this guy is coming from official supported module. You can use this for dependency injection. So for instance, I'm binding as this interface, this implementation class, as this interface, this implementation class. Or I could have just bind the implementation class directly. And then you can use or access the elements in the registry as you saw before, right? So I want the book service here that is coming from the context, right? The JSON rendering, where is coming from? So the Jackson module comes with the core module. You don't have to have anything else. But otherwise, if you wanted to use, like, I don't know, the Pack4j module, what you would do in the build.gradle, you would say something like compiled Ratpack, and then see, and then you say Pack4j. This is thanks to the Ratpack Gradle plugin. So they are already taking care of picking the appropriate version of Pack4j for you, so you don't have to. It's really handy. So about the rendering process, because all the time in the previous examples we've seen the render method with a string. That's obviously for demos, but not for real applications. So we want to render complex objects. We need something else, and that's the renderer API in Ratpack. So the way the render method works is that it looks in the registry for a renderer able to render that specific object you want to render, right? So we're using the render method here. We're rendering a book. Okay, a book is a bunch of pages. First of all, that was intended to be a joke, and it's also this class. Okay. So how does Ratpack know how to render this guy? He doesn't know, but you can tell him, right? So we have the book renderer class. This guy stands renderer support of book. Okay. We know you're there. So this is like another functional interface. You have a render method. You have like the context. The Groovy context is like the context version we saw before, but this is only like Groovy specific. So you have like a closures in the return times and things like that. And you receive the book object being rendered, right? And then using the context, you can make a decision depending on the accept header of the client, right? This is the by content method. So if the client wants JSON, you render JSON through Jackson. Otherwise, you're using Groovy Markup Builder. Do you know Groovy Markup Builder?
Why don't you use the default JSON support? I mean, JSON as well.
I could use it, but then I'll have to build the JSON by myself. In this case, Jackson is doing it. So I'm just saying, Jackson, render this shit, okay? And actually, if you know Jackson and the Jackson API, you could say like, I don't know, you could say JSON property, blah, 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 you know what I mean? Or it's like a JSON exclude, those Jackson things, you can use them. So by default, what Jackson will do is look into the properties, and for everyone will render like a JSON attribute for it. So this guy is in the context, and this guy will be used when this method is called. Okay. The overall thing, when no path is specified, then this will be printed, rendered. If welcome is specified, then we'll get the this template here, and then when we have this request here, we create like a book with this thing, and we render it as JSON. So let's see how this works.
So do you have to create a renderer for each object that you have, or can you have a general renderer that just checks everything?
Yes, you could have like a general renderer for that. Or actually, you don't do that. If you want to render any object, you just say like Jackson, whatever. Or, I mean, you can do that in a more fashion way using a renderer. Okay. So. We have hello JDD here, we do, and then if I say welcome, I have HTML, nice, and then we get like API, book, blah blah blah. We have a booking JSON with the ISBN as I specified. This is an actual book, by the way, here in Britain. What else from here? I think I have. This is a little bit more elaborated functional test, but is using the building blocks I showed you before. So the application under test and the test client with a delegate. There's nothing magic here. And for instance, when I make a request with no path, then I get hello JDD. When I make a request to this path, I get this response. When I make a request of type JSON to this URL, then I get this JSON, okay, and things like that. Or with XML, because actually we didn't test that, but we can do it. I don't see anything. So if I say -h roll singular application XML, we had a old-fashioned XML. Okay, makes sense. And finally, the asynchronous model. So the classical approach of traditional application or traditional servlet-based application is that you have a thread per request. So when a request is coming, there is a relatively large thread pool, like 20, 30 threads, depends, right? So the application server will pick a thread from the pool and will run the thread with your code, okay? And then your code will run, and there will be some point where your code will make a blocking operation, I/O, database, anything. So that will block you and will block your thread, and will cause that your thread will be unavailable for other requests that are coming, right? So that has some problems. First of all, we have to have a relatively large thread pool as opposed to a non-blocking approach. So for each request, we have a thread from the pool, and then the thread gets blocked with the blocking operations. The thread consumes memory. There is an overhead in CPU cycles to the context switching. It's not like a full processes, but there is still something, right? So the more you have, the more performance you're going to hit. In Ratpack, this is different. First of all, the I/O is event-driven. It's non-blocking. So this is using NIO too, actually. You know NIO, IPA from Java? So that means that you don't have like the socket class or the server socket class. You have like a channel or streams and things like that. And all those methods are non-blocking, right? That's all thanks to Netty. Netty is the underlying library. Netty is a low-level, very high-performant HTTP library for Java, implementing the NIO2 API. So thanks to that, Ratpack let's say leverages the non-blocking aspect. Also, you can see the handler chain is a pipeline of functions, and they are asynchronous functions, or they can be asynchronous functions, and you can compose them. We'll see that later. So the way that works is that there is a small compute thread pool. Let's say that I don't know the numbers by memory, but I think it's like one thread per CPU core, right? So that's 4, 8, or whatever, right? So when a request is coming, we take a compute thread from the pool, we execute code, and then when we reach a section that is marked as a blocking operation, depending on the API you're using, then the execution will be pulled out to a different thread, right? We have a different pool for that. So the original compute thread will go back to the pool, right? And will be available. That's why it's small. We don't need that much because they never get blocked. They get recycled all the time. They never get blocked. This message I'm telling you, they'll never get blocked. Maybe gives you something to compare with other frameworks. Because in Vertex, for instance, is the same thing. They call it the event loop, right? But it's the same approach. They just have different names for this. And it's not only that, but also you can integrate it with, they have like a core promise API, or you can replace that and use Rx Java underneath, which is really handy for promises and everything. Another interesting feature of the asynchronous model of Ratpack is that Ratpack guarantees a deterministic flow. This is very important because when you start to do things asynchronous, it can be hard to know when your code is going to be executed, right? So first of all, promises are executed in the order they are defined. And once the promises are resolved, they are executed in compute threads. So a request is coming, we take a compute thread from the pool, we execute code until we reach a blocking operation. When we reach a blocking operation, the execution goes to a different thread that does the blocking thing, and then when that finishes, we go back to a compute thread. And normally it's the same thread that originally serves the request. And also the API is defined in such a way that you can use like function composition, like do this, then do that, map, wherever, join, blah, blah, those things in a functional way. So you don't have like the callback hell with this nested codes. So let's see the last example. Validation. You are the previous guy. I don't like you. Yeah, you are the one I want. Okay. So we have here one handler, just one, right? And I've put numbers on the blocks to demonstrate the order they will be executed. So this will execute first, obviously, and then we'll go back to the bottom, because those guys here are blocking operations. So this is one of the ways. There are some others, but this is like the simplest way to indicate that an operation I'm going to do is blocking, right? If I were going to plug Redux Java underneath, the Ratpack API I'll use will be the same. It's only the implementation class they'll use, like the promise will be a Redux Java promise and not a basic Ratpack promise or whatever, right? So this guy here, I don't know if you see, but he's returning a promise, right? And the promise Ratpack class has methods to chain other things, like then I map this and then I do that and blah blah, right? So as you see here, this guy is going to be executed first and this one because it's defined first. So those are the order of the elements, right? I'm using thread.sleep to mark or to simulate a blocking operation, and this is like fulfilling the promise, basically, right? So I don't know if you have used Redux Java. So this is a little bit simpler, so you don't have like to work with full promise objects. So basically returning something from here is fulfilling the promise for you.
And then can you somehow change Redux Java promise, repeating your whole API to the Ratpack promise, so you can chain it here?
So the Ratpack API is what you will use, regardless of the library you use underneath.
Okay, but then let's say inside I'll have a service, that's my service,
Mm-hmm.
it doesn't have anything from HTTP, and it just returns a promise or a future from Akka. So can I somehow then translate it to Ratpack promise?
Yeah, you can. So I'm fulfilling the promise with a string that I am receiving in the next function of the chain, and I'm like I'm composing. So I return world from him, and then this guy will add hello on top of that, and the final guy what we'll do is to set the variable with the message. This is important about the execution. Because thanks to this, we can ensure that when this guy is executing, this variable is going to be resolved. This is extremely complex to do if you don't know very well what you're doing. For instance, in Vertex, right? It's not that evident to understand this. For sure, you will have to wrap it in a way and to put conditions on block and promises methods to ensure that this thing is going to be executed first. But in this case, Ratpack is doing that for you. The second guy will take like the message we compose here, and then we'll say that from JDD. That's coming from here.
Wow.
Sorry, there's only one thread for blocking operations.
No, there is a larger pool for blocking operations.
So when we are sure that the first blocking section will be
the order
completed
is
before
guaranteed,
the second
right?
blocking section is executed.
Because it's defined first.
Yeah, but it comes to the same
They
thread
won't
pool, yes. So
Yeah, but Ratpack handles that.
You don't use that for using in parallel, for declaring a lot of different operations in parallel and get them done faster. You use that so that you can have several external users hitting the same server with a small server pool, and then having this in like processing single request will not get faster because it will not get in parallel, but processing all of them will not actually hang the thread pool, the thread pull the thread from the thread pool that is handling the requests, correct?
Yes, but I think there are different concepts. So one thing is parallel execution, and the other thing is asynchronous execution, because for parallel execution, you don't need it. You can use Groovy.
Yeah, so the next question is it possible to achieve parallel execution here? Let's say we have 2 blocking operations, okay? But you don't need them in order.
In order,
Yes.
I think yes. I'm not familiar with, because they have changed this API for the 1.0 version. They have reached like 1.0 in 2 weeks ago or something like that. But they have been in 0.9x for 2 years or 3 years, many times. The thing that they didn't feel comfortable with like a final version until they were comfortable with the API. So they have been changing method names just to clean up, you know. So this was done before in a different way. I think this exec method will do that thing.
Okay.
But I'm not sure. I will have to check it and get back to you.
So this is funny, because you usually think in those terms that you mentioned, in parallel, running in parallel, right?
Mm-hmm.
But here you don't really. It's not about the single task running in several threads. It's about several tasks running in a single thread.
Correct.
And not blocking.
Correct. One, two, three, 4, 5, 6, 7. That's all. It's in order. And you can see the thread name. So we have a compute thread for the original request. So everything which is like outside of a blocking operation is on the compute thread. But whenever we need to execute a blocking operation, we switch to like a blocking thread from the pool.
So here you said that the compute thread, you're going to go back to the same compute thread that you started, but you don't have that guarantee on the blocking, right? I mean, with blocking,
no,
you can hit another thread.
Yes. The thing is that this is using the same blocking thread because this got available once the promise was fulfilled, and there's no other request, but potentially it could be any other.
And where do you tune up those pools?
There are configuration parameters. So there is a block you put.
Here in the. Okay.
Yes. There is like a server config block.
Okay.
And you define the server port, those things. Yeki, or whatever, or Curva. So, any other question so far?
I would like to ask about maintaining the Ratpack script, because sometimes it happens that you have, for instance, I don't know, 30 or 40 endpoints, and how you cope with?
So, if you have a really large application, you don't have to use the Ratpack DSL at all. You can use like a main class. So you can do it in the Java version with a lot of classes. You would use a class which will implement it's a server starter or server runner. I don't remember the name. That will have a method, and then you will make calls to the handlers method and things like that. And from there, you can or
Dispatch the request.
Yes.
Okay.
So you can get this as complex as you want, and it's true. I mean, if you need more classes, because maybe you say, all right, it's okay if I have all the handler implementations in their own class, but I still have the root matching in this class, and that can be large as well.
Yeah.
So you can have that in different classes if you want. So That's it.
How much Ratpack is there in the wild running in production?
Good question. I don't really know. I don't really know.
But Scalatra was very popular. I mean, Sinatra. And then Scalatra for Scala, which turned into Spray, and HTTP, and everyone is using that. So, whole world is using that concept. It was founders.
Yeah, the thing is that it doesn't have the hype of Vertex, for instance, and doesn't have a Red Hat behind it.
No, but on the Scala side of the world, this is how you do applications these days with those handlers and everything.
You mean that there's no traditional way of doing it like MVC and Spring and things like that?
No. Most people now do the Spray or HTTP, which comes from Scalatra, which comes from Sinatra.
Yeah.
So what would be the main difference? Like, because you are in a situation when you can compare Ratpack right now.
It's very similar.
Very similar. So the concepts are the same.
Except that the cell that here it's outside of the code. In Scala is inside Scala. Because in Scala you can do this crazy stuff with the operators and so on. But it's very, very similar. I mean, it looks almost the same.
Okay.
Let's see how many fans we have.
There's at least 120. Ah, it's two.
Two.
Woohoo! Can I talk to them? Why?
They got shy.
See, you shouldn't say that.
Yes.
They can now stop, so it's not.
So we can say swear words and